Hello, and welcome to Chapter 6 homework for anyone that wants to watch. This is your host, Professor Naragon, coming back at you to go over the homework with y'all and making sure that y'all understand what's going on. And also bringing you in some tips and tricks using Excel. So if you're ready, brave adventurers, let's go ahead and get started. So, for question number 1, we're going to compute the mean and variance of the following probability distribution. We have 4 numbers there, 8, 16, 24, 32 for x, and probability of x is being 0.10, 0.25, and 0.35, 0.30. So we're going to go ahead and see if we can pull that into an Excel file. I like to click it on to get the Excel files running so that we can actually perform our formulas. And I will always suggest this when we get into the more detailed formulas. I would have like a blank workbook and just start adding tabs to that as we progress through. Will help. You're going to see that in this video. Alright, so with this one, since this is more of a random variable, we're going to end up multiplying each one and then add them together. I know, fun, huh? So, let's go ahead and do that. We're going to find the mean. So, looking for the mean. So again, equal to our x multiply by a probability of x. And then the fun part, let me zoom in. Is on Excel, if you ever see this green square and we've already typed in the formula, we're going to go ahead and bring it all down so it can automatically calculate. Now that we have them multiplied out, all we have to do to find the mean for this random variables is go ahead and add them. So you can select them all and then go to formula and hit auto sum. So my mean should be 22.8. Always check, make sure, because we do need that mean for the next part to find that variance. So how do we find the variance? Well, we have to take the x, basically our x, minus the mean. So I'm going to put this up here. X minus the mean. And we're going to raise it up. So, raise to the power of 2. And then we're going to multiply that by our probability. So, right here, we got to input this formula into Excel. How we do this? Well, for any time that we have anything dealing with powers, exponents, remember, it's going to be the formula equals power, and then in parentheses we're going to put what our base is. Now our base is x minus the mean, so I'm going to highlight x and I'm going to say minus 22.8. Now, if I wanted to actually put this and select 22.8, I could, but you gotta make sure that you have 22.8 going straight down for how many X's you have. But this is fine right here since we're not really changing the formula at all. We can always fix it later. But for power, after you put in the base, make sure you put comma and the power itself. We're raising it to the second power. And then you would close parentheses to create the formula. But we still have to multiply by our probability. So, once we got the formula in, hit enter. And then again, we're going to drag down. And we're going to basically add them all together. So my variance for this random probability going on, random variables, is 59.36. And there we go. So that's question 1. But we always know question 1 drives a little easier. Let's bump it up notches, shall we? And we bring in question 2. So question 2 is a little bit more trickier, where we have figured out probability of vehicles that require warranty services. This is dealing with almost a probability of permutation formula. I'll show you how that looks as we go through. So industry standards suggest that 7% of new vehicles require warranty services within the first year. Okay. Jones Nissan in Sumter, South Carolina, sold 11 Nissans yesterday. We're going to round the mean answer to 2 decimal places and other answers to 4 decimal places. Alright, so let's go ahead and show this in Excel to basically how to do this formula for this basically probability of this counting method in a binomial, because this really is a binomial formula. So Excel, we're going to go ahead and use the book, or not book, the blank Excel, and variables that we will need will be in X and the percentage, probability percentage. So in our word problem, N is going to be the amount of Nissans we have sold. So that's going to be 11. X will determine whichever number they're asking for. So for this one, first question will be 0, none. Okay. So there's 0. And then the probability, or basically percentage. I like to say percentage because it is in percent. But the probability of likelihood of how many of these will be needing warranty would be 7%. Yes. Good old 7%. 0.07. Alright. So let's start building out this formula. First part that we need to build out is the premonition counting one. So that is n factorial divided by x factorial in parentheses n minus x factorial. And what we mean by factorials, these are the exclamation points. So again, n factorial divided by x minus x factorial. Alright, so I'm going to piece these out, the formula by each item that get multiplied, so you can see how it works and how we're doing it. Now, for factorials, the formula is fact. And all we have to do is then insert the number. So n, that is the 11, so we'll fit in that box. Now, if you ever need to go look up the formula, you can find it under Math and Trig. And there's factorial. You can also search for it if you need to by clicking Insert Function and then start typing in factorial. It will come up. So we're going to divide. And I'm going to put this all in parentheses. Fact. This is my x. And multiply by factorial of n minus x. And that's basically it. So hit enter. Oh, yes, I need another parentheses. Yeah, if you miss a parentheses, they will add it on, just like I did right there. So that comes out to 1. Next, part of this formula, we're going to take the probability percentage and raise it to the power of x. So p to the x. So equal. Now again, this is an exponent, so I gotta use that power formula. And then take RP, then hit comma, and then select our power, which is x. Close, and there's our answer. Now, last part is 1 minus our probability percentage raised to n minus x. So, get equal. This is another exponent, so power 1 minus our percentage. That's our base. And then our power is, of course, n minus x. Close parentheses. Then hit enter. And there's our calculation. So, now that I have all three components, the next step is basically just to multiply. So this one times this times this. And of course, 1 times 1 times 0.4501 is going to come out to 0.4501. So that should be at 0. So 0.4501. Check. And this will verify that our formula is actually working, which it is. So this makes it now, the next two, a little bit easier to calculate. Why? Because the only number that's going to change is our x. Now it's 1. The next one's 2. So I can just put in 1 and have it run the calculation. But I'm going to do something a little bit different here. Since I need multiple, I do need the multiple for later on, just to show y'all how I would do that. Let's do it this way. N X P. N is a constant right now, so it's just 11. X, we had 0, 1, 2. And of course, our probability percentage is the same. Alright, so for this, all I'm doing is I want to re-enter, but using the table. So N then this one's going to change. If you ever need to change the formulas, also, you see how I'm dragging the color? You can do this as well. And it will update right here, whichever box you decide to highlight. So it works well to do a quick one like that. Okay, now that I have it updated, this is what I was saying in question 1. You can do this, but you had to basically bring down multiple means. Well, now I have it in a table format. I can just drag. And this should be my answers. Again, I can always verify by seeing which box highlights. But for these two, since we're only doing till 4, let's go ahead and reduce those. So now it rounds for us. So I have 0.4840. And then C, since that was 2, is 0.5204. Then we're going to check just to make sure. Uh-oh. Looks like we got a problem going on. Huh. Let's see. Looks like we got rounding it. Oh. Yeah. I know y'all probably going, yeah, you just took this one. My bad. That tells you on that one. My bad. I forgot to drag on the last of the formulas. Alright. 3727. So you gotta make sure all formulas get dragged down. Alright. Chapter 6 couldn't be any more fun. 0.3727. And 0.1403. There we go. Forgot to drag down that last formula, but there's the answers right there. They are correct. So always double check. Make sure you drag down all your formulas if you do that method. It's perfectly fine. Alright, time to calculate mean and standard deviation. So mean in itself is going to be n times percent. Again, go into your PowerPoint. This is the distribution. Binomial distribution, sorry. So, n times our percentage. So, here, again, I'll just have Excel n times percentage. So 0.77. Again, check. We are correct. We can move on. Now the next one is standard deviation. And remember, with standard deviation, the first thing that we have to calculate after the mean is the variance. And then we take the square root of the variance to make standard deviation. So, for the variance in itself, again, using the PowerPoint, n times percent times 1 minus percent. So, here, we're going to equal, again, n, multiply by percent, and multiply in parentheses 1 minus the percent. So there's my variance. Now all we do is take the square root. So the square root, again, the formula is SQRT, basically an abbreviation of square root. And again, you can find that under the math formulas, or you can just type it in. So, this has to be 4. Yeah. Well, that's new. Alright, so again, 4. So we're going to try and check the rounding. 8462.8462. That should be my standard deviation. And there we go. So that's question number 2. So really with question number 2, the biggest thing was that whole probability and how to calculate that. Next, we're going to jump to question 3. Alright, so American households increasingly rely on cell phones as their exclusive telephone service. It is reported that 50.4% of American households still have landline phone services. We decided to randomly call 8 households and ask if the home has a landline phone. Alright, so again, we're pretty much looking at a binomial right here. So, we know, again, usually it's binomial because it's either going to be a yes or no on the landline. But we're going to have 8 households because that's basically the count. We're calling 8 people. So that's why it's 8 households that have a landline. How's the random variable distributed? Against binomial, and that's because really the question it states is a yes or no. There's only 2 variables that we actually have. Yes or no, did it go or did it not? Do you have it or do you not? So, what is the probability that none of the households in the sample group have a landline phone service? So you know definitely we're going to be using formulas. In your PowerPoint, you have, let's see, it is not that one. This fun one right here. Blow it up. This one with combination. Okay? Since you're watching the homework video, I'm going to show you a very easier way to calculate binomial probability. Okay? Again, we're in a business class. Most businesses are going to use Excel, so might as well know the formula in Excel. Again, as long as I keep finding new formulas as they update, we want to keep using them. So, I'm going to create a new sheet just for binomial. And we'll go ahead and name it binomial. And there's certain things I'm going to need to have for this problem. First off, we are going to need to know X. We're going to need to know how many trials there will be. So X is basically the number of successes. So we're going to put success. Trials, and then, of course, that probability percentage. So probability of that success actually happening, or from our thing that, from our word problem. Sorry. Alright. So, trials. We know we have 8. So, we can actually go probably 8, be 9 actually. 9 spaces. Why 9? Because again, even though it's 8 trials, we can have 0 or we can have all 8. Alright. Then the probability is not going to change, which according to mine, this was 50.4% of households. I wonder, how many of y'all have landlines still? I know I don't. So, 50.4, oh, 0.504. Always convert to decimal form. Since this is the same, drag down. Okay, so what is the formula that makes this very more easy for us? Now that we know the variables, we can actually input. Actually go on and tell it to go to formulas, more, and under more functions, we have statistical. And notice that there's one called binom.dist. Now don't worry, we're not going to use all these formulas in this course. A lot of these are more advanced, so we're okay there. But notice that's asking for these items that we just put in our table. So successes, that's our first blank. Trials, that's our second. And probability of success is our 0.504. Now it has this fourth blank called cumulative. This is the difference between cumulative and discrete. Since this is discrete going on, we will say false. Okay, and then hit OK, and it will calculate out our answer. And it does say 4 decimal places, so we're going to go ahead and put 4. So back to home, hit our little 0.00 and get to 4 decimal places. So this is 0.0037. And we're going to double check to make sure that our formula is working correctly. And there you go. So, if they decide to ask for any others, well, I can go right here again, click on my box to drag down the formula, and fill it out for the remaining trials or the numbers. So now that I have it already inputted, I can just look. So C says, what is the probability that exactly 5 of the households in the sample group would happen? Well, here in my table, I find 5, and it's going to be 0.2222. Again, check. Always check, because you never know what will build on the other. And you want to go ahead and make sure that connect shows you that that's correct. Now D says, given the probability distribution, what is the mean number of households with landline service? So this is a repeat of question 2's formula. Okay, so again, it's just n times the percent. So here, equal n, which is our trials, times our percentage, probability percentage, 4.032. Now, as you can see also, I mean, it's 4.032 because this is probability distribution. The mean number of households, usually that probably should have been a whole number just because it's a household, but they tell us 3 decimal places, we're going to do 3 decimal places. If they want it to the nearest whole number, they will say that. But logically, I can't have 0.032 of a household. Alright, now let's just ask for the variance. So again, the variance is our mean, basically n times percent, times 1 minus percent. So I'm just going to have this equal to this number, and multiply it by 1 minus our probability percentage, and we're looking at 1.9. Actually, this is going to be 2. Because as soon as no, 1.99999. Okay. Oh, nope, 3 decimal places. So yeah, it's going to be 2. It's gonna it's gonna be me. And again, Connect will have some rounding problems, but as long as you're you're close to it, it will count it right. If you are doing the calculations correctly and it's still counting it wrong, send me that email. I can see if you're just slightly beyond the rounding. But they do give a little leeway on the rounding. But that's it for question 3. Question 4. Alright. So in a binomial distribution, n is 5 and pi, which is our percentage, equals 0.28. Find the probabilities of the following events. Okay, so we have x equals 3, x is less than or equal to 3, and x is greater than or equal to 4. Alright, so if I use my book, we know we're only going to go up to 5 on this. So I'm going to go ahead and delete these last 3. And I'm going to input 5, 5, 5, 5. And then the new percentage is 0.28. Enter. And then scroll down. So once I enter all that, again, here's our calculation. So first question was if x equals 3. So that'd be 0.1138. check. We are still good. Next one says x is less than or equal to 3. So we got to do a sum. And basically we're going to sum these items. So equal to the sum of 0 to 3. 0.9762. Okay, now greater than 4. Since we only have 5 trials, that means we only got 2 numbers there. So this would equal to these two. Well, needed some. So 0.20238. Check. And they are correct. So that's how we solve for 4. Since we already got the binomial formula in, all it is go into Excel and plug it in, and then understand what it means for less than and greater than. Again, this is why I have it already in table form. Makes it a lot easier and a lot quicker. Next, question 5. This one now using Poisson's distribution. So it gives us mu equals to 2.0. Okay, and again, we can use Excel. So using Excel, creating a new sheet. I'm going to rename this to Poisson. Okay, so again, that just tells me my binomials right here and my Poisson is right there. And again, in our PowerPoint, if I want to go to that formula, this is the formula right here that we're going to be using. If we're going to not use the special one in Excel. But this one's basically mu raised to the power of x times e, which is a standard number, that's natural log, raised to the negative mu, divided by x factorial. Again, e is a constant, it's always 2.71828, and we can actually input each of these elements as we would for other formulas. But again, since you're watching this video, we'll show you the other way. So again, I need x, and then I need the mean. Well, so back to our problem. So our mean is 2, and our x is going to be 0. Okay, so here comes the formula. And again, we can find formulas and go to statistical, and then we're going to find Poisson. And there it is, Poisson distribution. Click. And it's going to ask you what is x. We highlight the box. Then we click here to mean. What is the mean? Then last, again, it has that cumulative. This is discrete, so this is false. So the answer is going to be 0.1353. Again, we'll bump it up. So 0.1353. And there we go. There's our answer. Now, the second part says, what is the probability that x is going to be greater than 0? Well, if this is the answer for equals to 0, we can't go below 0 So all we have to do is take 1 minus this number. So I can pop out the calculator, but we'll just use this. 1 minus that number right there. So it's going to be 0.8647. Check. And there you go. That's question 5. Rolling it on now. Now that we have Poisson and binomial, this should take most of the chapter now. So next, in a recent survey, 35% of people surveyed indicate chocolate was their favorite flavor of ice cream. Suppose we select a sample of 9 people and ask them to name their favorite flavor of ice cream. Okay. So, it's basically still a binomial, because basically it's either going to be chocolate or it's not. They're going to pick a different flavor. So, how many of those in the sample would you expect to name chocolate? So, again, we'll go look at the formula. And this is going to be our mean. Okay? So again, basically n times the percentage. This is how much we expect. Okay? So for this one, since we got 9, and we know it's binomial, I'm going to go ahead and do all 9. So 6, 7, 8, 9. 9. And there we go. And then the percentage is 0.35. Okay. Notice that it's already calculated the mean because I already have it in based on the table. But again, this is just how many times that percentage. So it's 3.15 that we expect. Now, I can't have 0.15 of a whole person. So it does say round to the nearest whole number, which is about 3. And there's our answer. And here we go. Since I've already done the chart, what is the probability of exactly 6 of those people in the sample named chocolate? Okay. So right here, make sure we drag down. And 6. Looks like it's 0.0424. Okay, check. Return the question. Then it asks, what is the probability of 6 or more named chocolate? Okay, so again, it's either equal to 6 and more. So we're going to be adding all these together. So again, equal to the sum in parentheses 6, 7, 8, and 9. Close parentheses. Looks like 0.0536. Okay. Check. And again, all correct. Yeah, the key is to really understand what the problem is asking and which one we're using, either binomial or Poisson. Okay. Again, binomial, you start to tell that it's usually a yes or no type of question. Even if it says they can pick as many different flavors of ice cream, all we're looking for is, did they say chocolate or did they say something else? So still a yes or no. There's only two really answers to it for that question. Poison can be range. Can have multiple different ones. So 7 says an internal study by the Technology Service Department at Leahy Electronics revealed company employees receive an average of 3.7 non-work related emails per hour. Assume the arrival of these emails is approximated by Poisson's distribution. What is the probability Linda Leahy, company president, receives exactly one non-work related email between 4 to 5? Okay. So, again, we're going to be using our our Excel, and we're using Poison. Now, this actually asks, X is 1, average is 3.7. So the probability of it being 1 in that 1 hour is 0.0915. Check. And there we go. So then it asks, what is the probability she receives 5 or more non-related emails? Alright. Here we don't exactly have an exact number of how many emails make up this average. But what we do know is that we have 5 as the bottom number. So this is 5 or more, so it has to equal 5 and then be greater. So if we calculate up to 4 and add those and subtract from 1, we'll get our answer. You're just like going, he just said a bunch of stuff. What is really going on? Well, here you go. So, remember, I gotta start out at 0. So I'm going to change this to 0. And we're going to go 1, 2, 3, 4. The mean does not change. And then we're going to drag down the formula up to that 4. Next, we're going to find the sum. So again, I'm going to go ahead and just use auto sum. And so that is if it's 4 and below, or 4 and less. So if we want to find 5 and more, we take 1 minus this number. Hit enter. Ends up being 0.3128. Wow. And there we go. Now we have to figure out what is the probability if she received 5 or less non-work related emails during this period. So now it's doing the opposite, but still using 5 as our base. So we gotta go ahead and add 5 to ours. So 5, drag down, and since my auto sum uses that blank still, notice that it updated with now 5. So it ends up being 0.8301. I always say if you're ever going to do auto sum, always have a few blanks just in case you need to add new items down at the bottom. Check. And there we go. And that's question 7. Rocking on. Question 8. 8 is great. Alright. So now we're looking at golfers right here. So the 1989 U.S. Open Golf Tournament has played on the east coast of the Oak Hills Country Club in Rochester, New York. During the second round, 4 golfers scored a hole-in-one. Wow. That's... You can already tell 4 golfers to do a hole-in-one on one hole. That is a very low probability. But it did succeed and happen. The odds of a professional golfer making a hole-in-one are estimated to be 3,708 to 1. So the probability is 1 divided by 3,709. There were 174 golfers participating in the second round that day. Okay. So, we will be using Poisson's method. So what is the probability that no one gets a hole in one on the 6th hole? So, biggest thing that we need to find is what is the mean. Okay, so we have a lot of things, we just don't have the mean. Let me see PowerPoint, and here's our mean. Basically taking our percentage. So we're going to take the number in. So here, this is for sighted. We're going to find the mean. And this is going to equal to N, which is the number of golfers. So we have 174 golfers. And multiply it by the probability percentage, which happens to be 1 divided by 3,709. Enter, and this is our mean. So 0.4691. Oh, 0.046. So we'll have it that. And as you can see, as we slowly progress on our X, so there's many chance for multiple golfers to hit hole-in-one. Notice how quickly the distribution really goes down. So for this one, it says if no one gets it. So if no one gets it, then that percentage is 0.9542, which seems actually logical. Oh, it wants 5 decimal places, so let's go ahead and put all 5. So one more. Add a 0, so 0.95417. Yeah, you definitely gotta make sure that you put it in correctly with the 5 decimal places, because again, Connect may mark it wrong due to rounding. But this does seem more likely in this scenario, if you know anything about golf, that it's extremely tough to get a hole-in-one. So most likely there's a higher chance that no one's going to get it. And check to make sure I enter it correctly. I did. And then they asked, what is the probability of one golfer to get it? Okay. Probability of 1. 0.04476. Okay. Check. And there we go. Again, using the tools that we have, Now, what is the probability that 4 golfers score a hole-in-one on the 6th hole? As you can see, there is no chance. Yet it happened. Again, probability is really just, again, an estimate. Can it happen? Yeah, still can happen. You can beat the odds. Just happens the odds for this one for 4 is 0, but it happened. And that's really it for this golf one. Alright, so let's bring in number 9. Number 9 is a little bit more work that needs to be involved, but still we're using Poisson's distribution. So refer to the baseball 2019 data. Compute the mean number of home runs per game. To do this, it tells us find the number for home runs, and then it's got a few extra steps. So we're going to go ahead and check out the Excel that we need. And for this, since I'm only looking at home run statistics, I really don't want to be looking at all these extra numbers. So I'm going to go ahead and hide them. Okay, so again, all I'm looking at is home run. So the first thing I need to do is find home runs per basically team. So again, auto sum. There we go. So 5,585. Again, bring it up a little bit. So there's our sum of all these home runs. So this is going to equal to this number divided by how many teams we have. We have a total of 30 teams. So 30. So this is the amount of home runs per team. Alright, so next we need to divide the value by 176, as that's the amount of games that have actually happened. Okay. Okay, so this is going to equal this number divided by 176. Okay, this is home runs per game season. And then we keep looking, and it does tell us one more thing. Then multiply by 2 because there are 2 teams in each game. Okay, so this is going to equal now to this times 2. And this is our home runs. Total home runs per team each game. Okay, so our mean for this, for Poison, is 2.1155303, so forth and so on. We're going to do 4 decimal places, so 2.1155. And now we find that one. Our Poison, porcine, and we'll go again 4 decimal places. Should seem about right. 2.1155. Okay, so there is our item. Alright, so find the probability that there are no home runs in a game. So for no home runs, we're looking at, they're back to 4 decimal places. Click. 0.1206. Check. And we are correct. Find the probability that there are 2 home runs in a game. Okay. Again, 2. Find our answer is 0.2698. Okay. Again, always double check every time you put in an answer just to make sure you put it in all correct. And then the last one, find the probability that there are at least 4 home runs in a game. Okay, so again, we're going to look at 4, since we already have it all typed in, equals the sum of 4 and down. So it's 0.9363. There we go. Check my work. Uh-oh. Find the probability that there are at least 4 home runs. Oh. I did that the opposite way. It's getting ahead of myself since the last question. But since it's at least, we're actually doing 4 and above. So, my bad. This sum is actually going to be this number. 0 to 3. And then we take 1 minus this number. And I don't have equal sign. Equal sign. And it's going to be 0.1643. Whew. So it was 0.1643. And there we go. I was actually thinking they were saying less than 4, but it's actually at least, so it's 4 and above. So 4 and greater. Anyway, watch out on the wording. Again, if it does mark it wrong, you may have to do it the other way. That's fine. As long as you're understanding, we're good. So, big thing is, again, is making sure that you're understanding how to solve these and create this Excel book. That's what I call it. You can even put down in here that is from chapter 6, so that you have something that's actually calculating and can help you out. Again, I will label every element so you know that you put the element in. From there, if you have any questions, please let me know. And that is going to conclude chapter 6.